Okay, so a population exists and has allele frequencies. Each allele, or gene in this case, has a frequency or an often occurrence that it occurs in a population. So, by definition, allele frequency is the number of times that the allele appears in a population. So, like how common is the allele? The higher the frequency, the greater the allele is in that population. Therefore, the more common it is. It shows how frequent the allele or gene is occurring. It's usually a dominant or a recessive one that appears in a gene pool more frequently. So remember, a gene pool, that is the combined allele of the entire population, like your options for reproduction output. And these allele frequencies, how often a trait or an allele occurs, it can be calculated. In my equation, P is equal to the frequency of the dominant allele and Q is equal to the frequency of a recessive allele. So in a given gene, the dominant variety and the recessive variety. So in a given population that only has two versions of this gene, allele, meaning that there's only a dominant version and there's only a recessive version of the gene, then the frequency of P plus the frequency of Q, the recessive part, is going to equal 1. Now we know that it's not always this simple, but there are alleles that we can discuss that the frequency is either or. You are either expressing the dominant allele or you are expressing the recessive allele. And by percentage of population, if we add those two together, then that should equal 1. So let me just do an example in allele frequency. So in a population of wildflowers, the red allele is dominant and the white allele is recessive. So if I have a 500 total wildflower plants in our population that we're going to talk about, so 20 of them are recessive. They are white colored wildflowers, and then 320 of them are homozygous for red, so they have both dominant alleles, and 160 of them are white carriers. They're still red, but they are a carrier of white. So how many total alleles for the flower color are there in this actual population? And how many dominant alleles do we actually see versus the recessive alleles? Frequency is going to be expressed in a decimal point. Even though we can think about it as a percentage, we want to express it as a decimal. So if I have 500 plants, that means I have 1,000 total alleles because every plant has either or. So there is 1,000 alleles total to account for. 20 plants are little r, 320 are big R, and 160 are, are heterozygous, so they're capital R, little r. So if we want to determine frequency, let's talk about what it means to be heterozygous. So if you are heterozygous, you are little r. So 20 of those plants are little r, meaning that there are 40 little r's to contribute to the population. And if I have 160 of them that are heterozygous, that means that they can all give one of those, and I'll give one of those. But of the 160 plants, all of them can contribute a little r. So I have 160 little r's to give. When I add all that up together, 160 plus 40 is 200. So of my 1,000 plants, I have 1,000 alleles. There's 500 plants, 1,000 alleles. There is 200 recessive little r's. So if you remember how to do a percentage, that is part divided by whole times 100, that's how you would do a percentage. But we want the decimal point version, so we just want part divided by whole. So 200 divided by 1,000 is equal to 0.2. Now remember, I had P and Q. P is my dominant allele and Q is my recessive allele. So my Q is 2. So if Q plus P equals 1, and my Q is 0.2 plus P equals 1, then P is equal to 0.8. So my frequency for the dominant allele is 0.8. And so this is my allele frequency for 500 plants. To clarify, let's just do one more example. So in a population of pea plants, the tall allele is dominant and the short allele is recessive. So we have 400 total plants in our population. 50 are short, so they're homozygous recessive, little t, and 200 of these plants are homozygous tall, big T, and 150 of them are heterozygous, big T, little t. So if we want to find our allele frequency, let's just say we have all 400 of these plants hanging out in a garden. What are my frequency that I will get a little t, a recessive allele, versus a large T, a dominant allele? How many of each alleles are there? What is my frequency of occurrence in my population of 400 plants? That's the question. Okay, so my frequency of alleles in a population, I have 400 total plants, which means I have 800 alleles in those plants. Of that 400, 50 of them are little t. So I am going to be able to contribute 100 little t's from the recessive plants. 150 of them are big T, little t. So 150 of those plants. So each of those 150 plants can contribute 1 little t. So I have now 150 little t's. So now I want to figure out the frequency of my recessive alleles versus my dominant alleles. So my frequency for the little t is 250 is my quantity. So I have 250 little t alleles out there in my population of 800 available alleles. So again, we're going to do part divided by whole. So 250 divided by 800, and I get 0.3125. So this is my Q, right? So Q equals that answer right there. All right, so if I have P and I have Q, and that equals 1, P is equal to, and so my frequency of the dominant allele, I subtract 0.3125 from 1, I get 0.6875. So this is my frequency for the dominant allele, and this is my frequency for the recessive allele in my 400 plant population.